8.2 Swyk 2, starting with question 7 here. We're evaluating the infinite series. We can tell this is geometric, right? It looks like an explicit form, or the explicit formula for a geometric, because it's based on the exponential form. And it's infinite, right? So we immediately go to, is the absolute value of 2 less than 1? As soon as we can say no definitively, ding, 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 answer to the question, done, just like it was in the last week, it's a no. I wanted to throw these questions in here again, but this time it's throwing it at you in the summation notation form instead of just a list of terms. Here's another good way to tell it's infinite. I know that's kind of obvious, but I thought I would share it anyway. Question 8. Another one of these summation notation. We can see that it's geometric because the equation is exponential. Can't think of what I'm trying to say. The multiplier is negative 0.2. Is the absolute value of negative 0.2 less than 1? Yes, it is. Therefore, it converges. Therefore, we use the formula. Okay. Now, I should have said, yes, it converges. Therefore, just like a baby, we use the formula. That joke didn't come out fast enough. All right, so we need to know the first term. We plug in a 1 to find the first term, right? 1 minus 1 is 0. Anything to the 0 power is 1. So we just figured out that the first term was a 1. Then we've got 1 minus r on the bottom there. 1 minus r, well, that does end up being addition. So we've got 1 over 1.2. And they didn't ask me for a fraction this time. So I'm not forced to use fractions. I do come out with 0.83 repeating, which has got a lot of 3's. And they wanted it rounded to 2 decimal places. So 0.83 would be a good answer to this question. On to the next one. We can definitely tell this is infinite because of the dot, dot, dot. Which also, they're asking me to write this in summation notation. So you can see on the bottom here, we start the index. They're using the letter I. And, ooh, I see a mistake in my formula already. Because okay, let me talk through this problem again. I already talked through it once, but I forgot to hit record. So, the mistake that I made was I was using N, and I should have been using I. Math Excel will count you wrong if you use N because they specifically down here use the index letter I. That's my fault. Okay. I don't know where I left off in this particular. Maybe I should go watch it. Nah. Okay. So we're starting with the first term. We're going through the infinite term, and we want the formula, right? We know that the first term is a 1. We know that the multiplier is negative 1/5, and we plug it in. That creates our formula. Remember to use the I. We don't need to write the 1 in there for the first term because it's a 1. We know Math Excel will know it's there. But these are the 3 things that you need for that particular formula. First term through the infinite term, and then we need the geometric formula in there. Okay, moving on down the road. So this family is starting to save for their vacation. And their vacation, they're going to start saving in March, and they're going to go on vacation at the end of August. They make a big deal out of that for a reason. The family expects the vacation to cost $1,596. They start with $130. At the beginning of each month, they plan to deposit 25% more. Okay. Now, we've got every percentage starts at 100%. We've taught you that. We're taking our percentage up 25%. Oops, up 25%. And if we go up 25%, that makes it at 125% of the previous amount. That, we've always taught you to convert that from a percentage to a decimal by moving it over 2 places to the left. Therefore, we get 1.25. Now, we called that the B value back in the exponential chapter, but it's the R, it's the multiplier. It's the ratio here in this stuff, 1.25. So we know we got March, April, May, June, July, August. We are making a payment at the beginning of the month. They made a big deal about that at the beginning of each month. So the payment's going in, even for August. The payment goes in before they go on the trip at the end of August. That's why there's 6 deposits. We want to add up all those deposits. And so we use the formula, $130, 1 minus 1.25 to the 6th power, over 1 minus 1.25. Plug it all into the calculator, we get $1,463.64. Obviously, that is not enough money to go on this trip. So they're going to have to make some changes to the old formula. Either they start with more money in their first deposit or they raise their percentage higher than 25%. So $1,596 is the target. If you subtract what they have, that's going to be $132.36. Now, you and I both know that if they want to go to the nearest dollar, it would be they would need $133 because $132 would not make it. I'm going to go check Math Excel right now to see if they're being stupid about it and seeing if they're rounding that down to 132, even though they should be rounding it up to 133. I'll be back. Okay, I've worked out a couple of their examples on this question, and none of theirs came out quite like ours did. Theirs all were above the 50-cent mark, and so they rounded up automatically. Therefore, just if you run into this situation, I personally would round it up. If they do something stupid and round it down, just remember that. I kind of mark that down, but it should be rounded up to 133. If they don't, if for some reason you come across this problem on the test and then you get it wrong, but for that reason, just shoot me a text or shoot me an email and I'll fix it for you, because that's kind of ridiculous. Okay, question 11 here. Back to the drugs. Lots of drug questions. If a patient starts taking 100 milligrams of a drug every 12 hours, then the amount of the drug in the patient's body after taking the 30th pill is given by the series shown below. Find this sum. Okay, so it's geometric, right? We're starting with 100 milligrams. We've got 0.68 or 68% of that left in the body by the time you take the next dose. And you're doing 30 different doses, right? So this is obviously over a 15-day period because you're doing this every 12 hours. So we know the starting amount, 100. We know the multiplier, 0.68. We know that there's 30 different doses that we're taking. And so plug it all into the finite geometric formula. We end up with 312.497. They say round to 2 decimal places, so 312.50. I'm sure it'll take it if you put 312.5 or, on this type of problem. But just go to 2 decimal places. I think that's it for this particular Swyk. And I think you're ready for the next assignment. Have a great, and then you'll be ready for a test. Talk to you later. Bye.